All right. Today's lesson is 5-6 Analytic Integrals. Today's date is Wednesday, November 20th, 2019. We're talking about analytic definite integrals. So definite integrals. It means you have a beginning, you have an end, my ladies. Okay, so let's talk about the different types of integrals. You've seen indefinite integrals up to now. You didn't know that was the name, but that was the name. So another way that we say indefinite integral is saying antiderivatives. So antiderivatives is slightly less formal than saying indefinite integral. If you say indefinite integral, you're being very precise. You're not being pedantic. You're just being precise. The indefinite part of indefinite integrals means that we just don't know where you started and where you ended. It's just taking the entire function and all the way from negative infinity all the way out to positive infinity. So let's just say don't know where to start and end. Don't know. Cannot spell here. Don't know where the start and end are. And you can even see that in your notation as well. So like if I take the antiderivative or the indefinite integral, my integral looks like that. And of course it looks like that. We've been doing that the whole time. But notice that there's no numbers from here to here. Sometimes we'll say, okay, between 1 and 2. There are no numbers, which means it's indefinite. So we say like indefinite integral of f of x dx. Does anyone remember this, by the way?
Isn't the capital F?
It is capital F of x, and don't forget your
Cake.
Don't forget your cake, your plus c. The dinner and cake, yeah. Don't forget to eat those delicious foods that you might be eating for dinner, or definitely cake. All right, my ladies. Let's talk about the definite integral, aka the integral. It's what you normally deal with, so aka the integral. So take a guess at what definite means. Precisely, my ladies. All right, so we do, capital D-O, know the start and end values. So, for an example, my ladies, we have this integral between, I'm just going to make them general, a and b. I could choose like 1 and 2. I could choose -5 and 20. I'm just going to say a and b, though. So if I take the integral, instead of the antiderivative, the integral of lowercase f of x dx, this is still going to be equal to capital F of x dx. Or sorry, not dx. We got rid of that when we took the antiderivative. But the difference now is there's no constant of integration. There's no cake. The cake ate itself. And that's a good way of thinking about it. The cake ate itself. So check this out. You always do an evaluation bar. It's slightly bigger than an absolute value symbol. Evaluation bar between A and B. That's just saying, hey, plug in B and then subtract what happens when you plug in A. So let's do that. Let's plug in B. I have capital F of B, and then subtract what happens when I plug in A, capital F of A. And you might be asking, well, what happened to that constant of integration? At the very end of this lesson, I will show you how the cake ate itself. So that is your formal definition of the integral. Whenever you have f of x evaluation bar between a and b, again, you always read it from here to here. That means I'm going to plug in b and subtract plugging in a. You understand? I read it f of x from a to b, but I'm going to plug in b, then minus a. That's going to be very important for the rest of AP Calculus. So here's our general procedure. First, you're going to take your antiderivatives. Like to get from here to here, right? The antiderivative of lowercase f of x, we got capital F of x. So first, the antiderivative. And then what do we do next? Then we kind of found that we were going to be plugging in these numbers. We're going to be plugging in B and then A. So I'm going to first plug in the end, then I'm going to plug in the start. So plug in the end and start value. And then you just simply subtract. It should always be end minus start, or B minus A. However you want to think about that. All right, my ladies, let's do example number 1. So, step 1, go. X cubed, evaluation bar, between 1 and 3. You read that correctly. Between 1 and 3. Stego, explain. What happened to that 3 in front of the 3x squared? This 3 seemed to disappear from here to here. Where'd that 3 go, Stego? Good, yeah, exactly. Because normally you'd be dividing by 3 when that goes up to a power of 3. And what is the next step? Arrow, do it for us, please. My lady. Careful.
You plug in the thing.
Plug in the end value.
Yes.
And subtract start value. I basically did that whole problem for you, Arrow. I'm going to have to give you another one.
I saw 9 minus 3. Is it 9 minus 3?
It is not 9 minus 3. What is 3 to the power of 3, Arrow? Yeah, it's up there on Arrow's new wall of cubes. It is 27. And 1 cubed is also not 3. It's also up there in a perfect cube of 1 times 1 times 1, Arrow, which is... What is 1 times 1 times 1?
I thought it was 3.
It is indeed 1. And Arrow, your final question is, what is 27 minus 1?
26.
Woo! I should box my answer.
How did I get that so backwards? I got that 9 too. I was just thinking 3 times 3. Yeah.
You have just done your first definite integral.
Oh.
Well, Arrow's done her, like, I don't know, 90th.
Do you plug it into the original value, or do you plug it into the derivative?
You always plug it into the antiderivative.
Oh, that was my mistake. Yeah. That's
always-
I
You would still get 27 because 3 squared is 9 times 3 is 27. Yes, so make sure you're always plugging into the antiderivative. That's what this evaluation bar means. It says evaluation bar, plug these values into this value on the left-hand side here. Sounds good. All right, so backside. Let's do another example. Ejemplo número 2. All right, go. First step, go. Stego, you got this one.
Okay, so I take the antiderivative, right?
Yes.
Does the 3x go to a 4x?
It's E house. So antiderivative and the derivative of E house is always just E house. But there's a problem. Yeah, she just said it. What is our inner? Before we take dinner, what is our inner? 3x. And for our dinner is 3. If the dinner is not 1, that means we're using... There we go. So, Stego, set it up for us. What are the 3 things we need? And then you can label them. U is... Next thing we need is... Taxman is 6. The E is part of the house, right? Because E house. U prime is 3. So we're paying the taxman 2. All right. Claire, you're taking over.
So then it's 2e to the 3x, and then interval is 2 to 3.
Oh, you're already taking the derivative?
Yeah, the derivative is just
Yeah, derivative and antiderivative are the... Or sorry, you were taking the antiderivative. Antiderivative and derivative of E house is just E house. So it is 2e to the 3x evaluation bar between 2 and 3. You want to do one more, Claire, or do you want to give it over to Arrow? All right, let's do it.
So then it's 2e to the 6th.
Careful. 2e to the...
Where did we get 8?
That is a 3. It's just poorly written.
But, oh, because it would be 9.
It would be 9 first. Yeah, you plug in this value first. So 2e to the power, and I can zoom in here. I don't know why I'm always zoomed out so far. 2e to the power of 9 minus 2e to the power of 2. 6. Teacher error.
You also got one of mine.
Yeah, log it. Both of you guys can get it. Both of you ladies, miladies, can get it. Alright, milady Arrow, please simplify this for us.
Oh, is it?
It is not, but it is a good attempt. If you can simply factor out,
Oh, it must be. I will do it.
what is the greatest common factor that you can factor out of both of those two terms, milady?
It is 2e to the 6th.
Perfect, and what is left over?
One of them is going to be 1. The other one is has 3.
E to the power of 3.
Really keep the oh yes.
You always keep the variable so you can have the power.
3 minus 1.
Minus 1, there it is.
Yes.
Cool, so you should know how to factor these guys because it is, like, these are the types of questions that I'll say, okay, you take the integral and then you do something with it where you might need to factor it. So, I mean, technically this black should have been our answer, but knowing how to factor it, I'm going to say that both of those are answers. So far, so good. Let's talk about how the cake eats itself. It's a magic trick, right? So where is the constant of integration, my ladies? Well, let's test it out, right? So if I have this integral, this derivative now, or sorry, I'm saying integral correctly. This integral between 1 and 2 of f double prime of x, that should theoretically be equal to what? F prime of x, Milady Claire has it correct. Evaluation bar between where and where, Stego? Careful, careful, you read it the other way around. Between 1 and 2, perfect. And you should get the answer of f prime of 2 minus f prime of 1. So we know that, but now I need to show you why we don't have an A cake, why we don't have a C, no constant of integration. So this is where it went. Again, the same problem. What we really could be saying is, okay, when I take the antiderivative, yes, you get the f prime of x. Let's go ahead and say, yeah, well, let's add the cake too, because the constant of integration, you should still have that when I take the antiderivative. And then same thing, evaluation bar between 1 and 2, right? All we're doing is, it's the same thing, we just added our constant of integration. We added our cake. Now let's go ahead and evaluate that. So we should get, this is equal to, now I'll choose a different color here. Now let's plug in 2. I get f prime of 2 plus our cake, plus c. That was the first part. Now I'm going to subtract when I plug in the second part. That's going to be f prime of 1 plus c. And that should all be in parentheses because I'm subtracting all of the first quantity, doing first quantity minus second quantity, or I'm subtracting this. We don't, and here's why. This negative sign distributes into each of these two terms, so it's negative, negative, and the c's cancel out as Claire just said. So I really am canceling out these two c terms, and I'm left with f prime of 2 subtract f prime of 1, which is exactly what we got up here. Where are you coming from right now? Okay. Cool. So the cake ate itself. Kind of cool, right? All right. That's all the notes I have for you guys. You may now begin on the homework. Good luck.